Punjab. Our next speaker for today is Dr. Rinchan Mirza, who is a DPhil in Environmental History from the University of Oxford. His research interests are in the economic history of South Asia. His research contributes to History Matters, substandard literature on economic history. And most of his research focuses on the critical junctures and how they interact with small differences in initial conditions to cause nations to diverge in terms of their long-term economic development. The geographical area he concentrates on is South Asia, and the critical juncture he utilizes come from the British colonial period. His talk today focuses on irrigation in the context of the Green Revolution and agricultural development in India. I invite him to come to stage. Thank you.
Hello everyone, this is a project that it's very much a work in progress, so any comments if you might have would be very useful. Unlike the earlier presenters, I apologize in advance if this presentation is a bit dry, because I'll mostly be talking about data and the data set I collected, and I did some analysis on it, and unfortunately I'll be talking about averages because as an economist, we have to predict things. In terms of predicting stuff, it's always in terms of talking about averages, it's be restricted by that in terms of our what we can do with the data. So my talk today is on irrigation. Can anybody hear me well? Okay. So my talk today is on irrigation, the Green Revolution, and agricultural development in India. This is something that I've been working on for my PhD thesis, and now I'm developing it further into a possible paper. I'll be focusing on India because that's where my data set comes from, and it's a very detailed analysis of how irrigation interacts with the Green Revolution, which was in agricultural technology, which came in after the 1960s, and how that interacted with the pre-existing irrigation infrastructure across districts in India, and what that meant for long-run agricultural development. In the end, I'll also talk about some implications for other development outcomes, but I'll mostly be focusing on agricultural development in this presentation. Okay, so what is the question that I'm asking in this paper? Essentially, I'll be looking at trying to answer this question: did historical irrigation infrastructure facilitate long-run development, agricultural development in India post the Green Revolution? The motivation for looking at such a question is essentially threefold. So we know that the Green Revolution had an immediate impact on agricultural yields of the two main staple crops in India, which is rice and wheat. We also know that the Green Revolution is possible in large part due to the pre-existing irrigation infrastructure. Right? So the literature of this is very detailed, that the controlled supply of water which irrigation provided was a crucial ingredient in terms of adopting the high-yielding varieties, which primarily was the Green Revolution. So these high-yielding varieties of both rice and wheat, where there was more material, which could, the plant growth was such that would give more output per unit of acre of land. So that was the main reason behind the Green Revolution was pre-existing irrigation infrastructure. We also, what we really don't know much about is how much of the Green Revolution itself happened because of the pre-existing irrigation infrastructure that was there, which possibly was linked to investments in canal irrigation during the colonial period. So I will try and show to what extent canal irrigation persists, the influence of canal irrigation persists to even today. One of the things that I want to highlight is that after the emergence of the Green Revolution, especially in India, groundwater irrigation became a lot more important. That was because of the fact that there was electrification of villages, and it was much more easier for farmers to install an electric pump and use that pump to use groundwater irrigation for the purpose of agriculture. So I do see some declining persistence of canals post the Green Revolution period, but they still remain very much important later on as well. So what do I do in this paper? This paper uses the extent of irrigation prior to the Green Revolution as a measure of initial irrigation infrastructure advantage to determine the impact of irrigation on yields post-partition. First, it shows that areas that have an initial advantage in terms of irrigation infrastructure experience greater increases in wheat yields immediately after the Green Revolution. So there was a jump in wheat yields immediately after the Green Revolution, and I'll show you that. But later on, the kind of areas which were not very well irrigated did manage to catch up. So, in terms of wheat, it's a story of an immediate impact of the Green Revolution in terms of yields, but then later on, areas with, relatively less irrigation tend to catch up. However, in the case of rice, this isn't the case. In the case of rice, as I will show, not only did the Green Revolution lead to an immediate increase in yields for rice, but this kind of increase persisted throughout the post-Green Revolution period. And this has to do a lot with the kind of development of those initial high-yielding varieties that took place after the initial phase of the Green Revolution. So I'll talk a bit more about why there is this heterogeneity between rice and wheat in terms of the impact of irrigation on long-run agricultural development in India. So I'm not going to go through in much detail with the empirical strategy because, it's not really that that engaging. So, but I'll just give you a basic idea of what I'm doing here. So essentially, in economics there's this thing called the identification strategy, which means that the results that you're about to show, whether they actually have a causal interpretation or is it just some random correlation that you're showing. So I've tried to do some empirical exercises to make sure that there is some evidence that this is causal and not just a correlation between two variables. So the first component of my identification strategy is that my measure of initial irrigation infrastructure comes from the past, right? So I go back into history, which is, here I'm using 1957, but that's still way before the Green Revolution hits, which is like the late 1960s. So in a sense, it's plausibly more exogenous than modern measures of irrigation infrastructure. Moreover, I use the same date for the Green Revolution, and this is an important point, because the adoption of the Green Revolution in a particular district could be determined by lots of endogenous factors which are very specific to that district and might not have anything to do with its ability to adopt high-yielding varieties or its ability to increase yields. So in order to control for that, I've kept the kind of date for the start of the Green Revolution the same across all districts of India, which means that it's more exogenous. It's not related to local factors at the district level. It's a national level measure of the start of the Green Revolution, and that's what I use, which is more exogenous. I also include what are called state fixed effects and district fixed effects. So by including a state fixed effect, I'm actually comparing yields within a state. So I'm comparing yields from district A with district B remaining within the same state. So I'm keeping essentially all things that could vary across states constant. So that is important again in terms of making a causal interpretation. And not only that, I also include district fixed effects, which means I'm comparing household A to household B or farm A to farm B within the same district. So so that's even a narrower band within which I'm doing this comparative analysis. And I include a whole host of control factors, so to to partial or to kind of explain out the effect of rainfall, explain out the effect of temperature, so on and so forth, which could also have an impact on yields, aside from their impact on agricultural technology. And finally, I cluster my standard areas at the district level. Okay, so this is a very quickly, this is my main empirical equation. On the left-hand side, I have yields, which is a measure of agricultural productivity. On the right-hand side, I have my main experimental variable, which is called Irrigated 1957, which is the fraction of total cultivated area in a district which was irrigated in 1957. And this is measured at the district level. I've multiplied that by what we call a dummy variable. A dummy variable is a simple variable which either takes a value of 0 or 1, depending on whether the year from which the data is coming is prior or after the Green Revolution. So it's like a pre-post dummy for the Green Revolution, and it's multiplied by the fraction of total cultivated area in 1957 at a district level which is irrigated. Now, the coefficient, which is the beta on that variable, the first variable on the right-hand side, that will tell us whether post the Green Revolution, districts which had relatively more irrigation perform better in terms of yield relative to districts which have relatively less irrigation relative to prior to the Green Revolution in terms of post. Okay, so where does the data come from? I collect district level data on crop yields from a combination of the World Bank and Village Dynamics in South Asia dataset. This is an annual level data set at the district level, which has a whole host of data on agricultural outcomes like yields and like crop yields aggregated by different crops like sorghum, wheat, rice, so on and so forth. And it goes from 1957 to 2009, so it's like a very long time frame that I'm looking at in this paper. There's also data on the fraction of cultivated area that is irrigated as early as 1957. So like this goes back way before the Green Revolution, which there's some ambiguity on when the Green Revolution starts, but most people agree that it's during the late 1960s that the Green Revolution kicks in. And I also do this analysis of persistence, as I mentioned, with the colonial period. So I also take data from the Agricultural Statistics of India on irrigation, fraction of cultivated area that's irrigated in 1937. That's my historical measure of canal infrastructure. And the data on the Green Revolution, or in other words, the high-yielding varieties, comes from, again, the Village Dynamics in South Asia dataset, which has for the 5 major crops of India, which include wheat and rice, the total area that was devoted to high-yielding varieties. So this will tell you how much of an area in a district was devoted to high-yielding varieties of wheat, and how much was devoted to high-yielding varieties of rice, and so on and so forth. And that's that's my measure of the extent of Green Revolution. So if your district plants more area to high-yielding varieties, that means you have more Green Revolution as opposed to some other district. The way I define that my post variable of when the Green Revolution hits India and when it doesn't depends on, I've used 3 different dates for that. So the first year in which the total area planted to high-yielding varieties of seeds for all India either exceeds 0%, the first year if it exceeds 2%, and the first year if it exceeds 4%. So these are 3 potential dates for the start of the Green Revolution that I use. So I would actually now skip to the interesting bit, I guess, which is of this paper. So my main result is that I find a positive and significant coefficient. Sorry, it's right at the top, and I can't really manage to bring it to the middle. But a positive and significant coefficient on my main variable, which is the interaction between my Green Revolution start period and irrigation infrastructure. So this tells me that districts that had an initial advantage in irrigation infrastructure and the ability to adopt high-yielding varieties experienced greater increases in both rice and wheat yields after the Green Revolution relative to before the Green Revolution. And here are the results in more detail. I'm not going to go into that, but just, the general message to get from this slide is that the top panel is wheat, the bottom panel is rice, and you have a positive sign on all the coefficients, and they're all significant. The stars mean that these coefficients are significant, so which means that for both wheat and rice, I find a positive and significant effect of improving yields of districts which have more irrigation infrastructure prior to the Green Revolution, relative to after. But what's interesting is this is a general result, right? So this is on average how Green Revolution impacted rice and wheat yields. But the next question is whether the impact of the Green Revolution was different for rice as opposed to wheat. Is there any heterogeneity in terms of whether Green Revolution helped rice more or helped wheat less, and how that relationship evolved? So I looked at that relationship as well, and the two main insights I get from that is essentially encompassed in these two slides, these two figures I'm going to show you. So here I've plotted the impact of irrigation, irrigation prior to the Green Revolution, in other words, historical irrigation, on annual wheat yields. Right? So this is the relationship as it evolves on a yearly basis from 1957 to 2008. As you can see, historical irrigation has an immediate impact around 1960s. There's a huge jump in wheat yields. But then, once you get into the early 1970s, this impact disappears, and you pretty much have a more flattish line. I mean, although there is a lot of jaggedness in there, but it's not an increasing trend. The increasing trend is only the initial part of this graph, and then you have a flatter, kind of line after that. So, in essence, what this means is, in the initial phase of the Green Revolution, irrigation matters for wheat yields, but later on irrigation doesn't, or areas which have relatively less irrigation prior to the Green Revolution tend to catch up. And there's a reason for that, which I'll explain in a bit. Here we have the same graph for rice yields. Now, rice gives us a very different story from wheat. Here, as you can see, not only does the Green Revolution have an immediate impact on rice yields in areas which had relatively more irrigation, but the impact of irrigation remains relevant throughout the post-Green Revolution period. So areas with relatively more historical irrigation tend to continue to do better for most of the period after the Green Revolution. Now, why is it the case that there's a differential impact of irrigation in terms of both wheat and rice? Well, first of all, this goes back to the history of how the high-yielding varieties of wheat and rice were developed, and had different trajectories. So what happened with wheat was the high-yielding varieties of wheat were very successful in the initial phase of the Green Revolution. In almost all areas of India, the high-yielding varieties of wheat had penetrated. Wherever wheat was grown in India, most of the advantages had been taken from the high-yielding varieties. They had been adopted very widely in those wheat growing areas, and hence those wheat growing areas had done well very early on. And then in the later phases of the Green Revolution, the high-yielding varieties that were developed were more for rain-fed areas as opposed to irrigated areas, and then we moved from irrigated land to more rain-fed land, and those high-yielding varieties were more adaptable to more marginal conditions. So the research tended to move from focusing on only areas which had irrigation to areas with more marginal environments. And hence you have the kind of catching up of marginal areas or rain-fed areas in terms of agricultural yields right after the initial phase of the Green Revolution. It is a very different story with rice. So with rice, irrigation remained a very significant factor because, first of all, rice is grown in a very varied agroclimatic conditions in India, and secondly, the kind of research on rice has not managed so far to penetrate more marginal areas. Unlike wheat, the research there needs to be developed further to kind of make the high-yielding varieties more adaptable to to more marginal areas which are not very dependent on irrigation. So that's the kind of first key insight from my paper. The other key insight that I try and draw is the extent to which historical irrigation has an impact on yields post the Green Revolution. Right? So what I showed you now was 1957 irrigation and how that has an impact on yields post the Green Revolution. I extend this analysis further back to the colonial period, and then I ask a specific question. To what extent did investment in canal irrigation during the colonial period matter for long-run agricultural development after the Green Revolution in India? Now that's a very interesting question because this links it back to history. So to what extent is the differences in yields over the long run in Indian districts determined by investments that were made way back in the colonial period? Well. Here I get a very, startling and very interesting result, which is that if I simply switch my main variable by including the share of canal irrigation in 1931 rather than including the share of irrigated land in 57, but I just focus on canal irrigation and I go back to 1931, I get again a significantly positive effect, and the magnitudes are larger. Which means that a lot of the effect that I just showed you of 1957 irrigation having an impact on post-Green Revolution yields actually extends back to the colonial period. Right? So a lot of the impact that has been made on agricultural development still dates back to investments that were made during the colonial era in India. So, but what's interesting then is to ask the question, so now that we know that colonial investments in canals do have an impact on yields post Green Revolution, what would be interesting to know is to what extent does that impact either increase or decrease over time? Right. So what is the trend? Is it remain stable or has it increased over time or decreased over time with the advent of the Green Revolution? Here, I've essentially plotted those coefficients with their confidence intervals, and this essentially tells what the main message to take out of this graph is the trend. Right? So, what is the trend of these vertical lines? Is it an upward trending? Do you see an upward trend or a downward trend? Well, here you see a stable trend till the early 1970s, and then you see a downward trend. What this tells us is that up until the 1970s, early 1970s, colonial canals have a very stable effect on yields in India. But then their influence on yields tends to decline or diminish after the 1970s. And a potential explanation for this, again, as I mentioned earlier, is groundwater irrigation. Right? So once Green Revolution hits India, groundwater irrigation becomes very important. And a lot of those areas which did not have or which were not historically canal irrigated now can use groundwater irrigation for agricultural purposes and for adopting the high-yield varieties of both wheat and rice. So the message here is yes, colonial investments in canal irrigation matter, but they matter less so after the Green Revolution because of the fact that groundwater irrigation then picks up and becomes such an important aspect of the Indian agricultural economy. Here I do a series of robustness tests, which in economics we further do some tests to highlight that our results are not spurious and then they're robust to excluding outliers. What we call outliers are extreme values. Are they driven by extreme values or is it really a mean that's driving the result? So I do that and my results hold, dropping extreme values. Another robustness test that I did was, whether, so if this effect is really about irrigation, then this should not hold for crops that are not very highly intensive in terms of water use or irrigated water use. So I looked at other crops aside from wheat and rice, and more specifically those crops where the water requirement was not as high, and I either got no result, no significance in my result, or I got a very weak result. result in terms of they were not, irrigation tended not to be very important for those crops, which again convinces me and hopefully you, the audience, that it's really to do with irrigation and not anything else that I'm catching in my results. And I did some other tests for robustness purposes. So these are all the results which I won't really go through because they all show different ways of doing the robustness exercises. In the conclusion, what I would like to say is that there's potential to extend this research. So far, I've only focused on agricultural outcomes, which as an economist is interesting, but it's not really what economists do. I now want to some kind of development outcome. And one potential way in which I'm trying to develop this paper is to look at the impact that the Green Revolution had on internal migration within India. Right? So there's this paradox even today that why is it the case that despite so much growth in India, so many people are still based in rural areas. A large part of the Indian population still lives in rural areas despite so much growth in sectors which are related to more urbanized locations. So why is urbanization not really picked up with Indian economic growth? Part of the reason could be the fact that Green Revolution meant, the success of the Green Revolution meant that it was not attractive anymore for people to migrate from rural to urban areas, and because the agricultural economy developed, and certainly in Punjab we have evidence that, Indian Punjab we have evidence that there's a lot of dynamism in the Indian Punjabi economy. And hence that could explain part of the reason why there has been, not enough growth of urbanization in India. That's one potential outcome. There are other development outcomes that I've been working on. Another potential is infant mortality. To work to extend this Green Revolution or irrigation for that matter affect infant mortality. And there's another paper where I'm working on with a few other co-authors where we show that there's been a significant drop in infant mortality in districts which had high irrigation. And because of high irrigation, they adopted the high-yielding varieties a lot more. So that really helped in terms of reducing infant mortality in India. So yeah, so those are the potential extensions of the work. So as I realized, most of you might not have been interested in the results that I showed, but it'd be very interesting to know your views on how to explain some of these results, and that's the phase in which this project is right now. So I'd like to thank you for your time. Thank you.